welcome to the third installment of the Sciences of the Face webinar series. This is the very theoretical bet at the core of the project that hosts this webinar series, that is the project Facets, Face Aesthetics in Contemporary E-Technological Societies, funded by the European Research Council, and whose PI, Massimo Leone, based on Turin and Shanghai, and a bit there and bit there, always traveling all around the world, is a world-leading semiotician, but is also drawing on other disciplines to unify the study of the face and of face representation. And today we are here to talk about neurocognitive contribution to the understanding of face and face action. Please refer to the Facets official website to get more info about the project. And let's go to the YouTube if you missed some of the intriguing presentations the other day. Also, if you have a spare paper on face-related topics, which tries to put forward the dialogue between semiotics, philosophy, and cognitive science, you might be interested to submit it to the call for papers. What's so special about faces on the journal Topoi? Topoi is quite a good journal. It has quite an impact factor, and the editors, Viola and Leone, have been told to be relatively merciful as compared to other editors. So merciful indeed that the deadline will probably be postponed by a 4 week or so. So if you want more information about this, just write me an email and I will provide you. But now, I quit speaking about the general picture and I focus on the very speaker we have today. It's quite a pleasure that here for this sixth webinar, we have nothing but no one else than Fausto Caruana. Now, I could say that Fausto is a philosopher turned to neuroscience, a bit like Anakin Skywalker, if you wish. But he, like Anakin or Darth Vader, he often comes back to our bright side. He is one of the leading figures in Italy and Europe in jumping from humanities to cognitive science. A leading neuroscientist, especially in the fields of loafing and of motor simulation. He worked together with Rizzolatti, Gallese, and other prominent names in the field to develop the embodied cognition account of emotion and emotional perception. And he also wrote a lot of great books like Il cervello in azione with Anna Borghi, or that very cool Come funzionano le emozioni with that Marco Viola you might have heard about. But now I want still Fausto all the joy of bragging a bit about. I want to do all the flattering stuff myself, because it's time that I let him present his newest take on a topic he has deeply thought about, also with the cognitive semiotician Claudio Paolucci, and that today he will present in a new experimental narrative. So, Fausto, I've spoke a lot, and now it's time for you to share the presentation, and the floor is yours.
It is probably the most difficult part of the talk. Should be okay? Am I okay? So thank you for inviting me, first of all. I will discuss about the hypothesis of two simulation systems in the human frontal cortex, and basically all these stories start from this guy, Alvin Goldman. So the story starts more or less 15 years ago when Alvin Goldman, the father of the simulation theory, proposed that other emotional expression trigger an automatic inner simulation in the perceiver, the so-called simulation theory, and that such simulation can be accounted for by a limited number of mutually exclusive computational models, At the very beginning, it was, and there were 4 different models. Then, as I would say in a while, it seems that more or less only 2 models survive these 15 years. So exactly today, 2 models are still in the spotlight of cognitive neuroscience. You can see in the left and in the right panel a schematic sketch of the two models. And the first model is called reverse simulation model, and it works more or less like this. First of all, an agent display an emotional expression. The individual here on the left, maybe I can try to highlight using, okay, this guy expresses emotions, and immediately the same expression is mimicked in the observer motor system. And basically, this is not an emotional contagion, it's just a replication of the opposite facial expression in the observer motor system. And we know this can be conveyed by means of the mirror neuron system housed in the motor system of the observer. And we also know that observing facial expression automatically trigger the so-called facial mimicry, an automatic facial mimicry in the observer. So this is the first step. Subsequently, there is another step from the motor system of the observer to the emotional system of the observer, this second step. And this is based on William James' theory of emotion, today on the facial feedback theory. So the hypothesis that the motor pattern in the motor system directly activate the emotional pattern in emotional brain region, okay? So it's a kind of step-by-step procedure, the one described by the first reverse simulation model. First, mimicking the observer expression, mimicking the agent expression in the observer motor system, and then the motor system asks the emotional brain to interpret, if you want, what has been mimicked in the motor system, okay? And then at the end, we have the attribution of emotion to the agent. On the other end, the alternative hypothesis is called a mediated mirroring model. And this model suggests that emotion and expression are encoded in partially overlapping systems. And these networks are directly recruited or activated by the passive observation of other expression. In other words, when I see another individual expressing, for example, fear, pain, happiness, this information is directly projected from the visual brain to the emotional brain. Skipping the step in between, the motor step, okay? And for those of you familiar with pragmatism and phenomenology, the second account is more in line with, what has been discussed by phenomenologists, pragmatists, and so on. There's a quotation here by George Herbert Mead. He says, what we see in the face and attitude of others is not the face of the body, it is the indication of certain sorts of conduct and the evidence of the feeling that conduct involves. We see the common acts and feel the value which express themselves in this action. We feel, first of all, the emotional content that accompany the social stimulus. So it is not mediated by the motor system. This is the second account. Now, if we look what happened in the field of cognitive neuroscience today, okay, it seems that when we discuss today about the neural basis of the processing of other smile and laughter, many scientists implicitly use the reverse simulation model. So this, for example, is an example by Paula Niedenthal and other co-workers about how the simulation works. And if you pay attention to this picture, there is, first of all, the involvement of the visual system, then via the mirror neural system, the recruitment of the sensory motor simulation housed in the motor system, and then via the so-called William James step, if you want, the subsequent activation of the emotional system. So according to this model, very influential actually, first there is an activation of the visual system, then motor and premotor regions, and subsequently emotional regions. So this picture is clearly coherent with the reverse simulation model, even if it is not explicitly mentioned in the paper. I mean, the system underpinning this model is the first one. This is another example from Chakrabarty and Simon Baron-Cohen, which is not the same Baron-Cohen, maybe some of you can think about. No? It's a very important psychologist studying theory of mind and other related issues. And according to this model, again, first of all, we have the activation of the visual system, because this STS is the superior temporal sulcus encoding biological motion from a purely visual point of view. Then there is the activation of all this region, inferior frontal gyrus, premotor, inferior parietal, frontoparietal circuits involved in the voluntary motor, in the voluntary control of behavior, so the voluntary motor system. And then subsequently, there is the activation of a cohort of emotional regions, including the amygdala, the insula, the basal ganglia, and so on. So here again, what is the model underlying this picture? Once again, the reverse simulation model. However, in this review that we wrote a couple of years ago, we showed that from a purely neuroanatomical point of view, emotional regions such as the amygdala, the anterior cingulate, the region here in red, PACC means anterior cingulate. So for brevity is the anterior cingulate, the anterior insula, and the amygdala, three very important emotional regions in our brain, are directly connected with visual regions encoding facial expression. So basically the visual system project information to the motor system, but at the same time, it can directly reach the emotional brain region without, the intermediate activation of the motor system. So there is a kind of direct access to the emotional brain. So in principle, from a purely neuroanatomical point of view, the unmediated emotional mirroring model can be supported as well, because in this case, of course, the emotional system is directly activated by the visual system without involvement of the motor structures. So the question is, does the observation of other facial display directly activate emotional brain region in line with the emotional mirroring model, or does it activate the motor system and subsequently the emotional brain as predicted by the reverse simulation model? And the problem is that to answer this question and to reveal the possible function of the simulation, first we need to know what is the contribution of this region of the motor system and the emotional system to the production of emotional expression. And this is not trivial because very little is known about the neural substrate for the production of emotional expression for a very, intuitive reason. It is very difficult to elicit real, genuine emotional expression, for example, within a fMRI scanner or in a psychological, in a psychophysical lab. So we know from a long-standing neurological tradition that, for example, primate vocalization, I will talk about laughter, which is, first of all, a specific type of vocalization. Both human and primate vocalization is controlled by two systems. The first one that you can see in the right part of the slide is the voluntary motor system. Okay, the motor system is involved in the production of voluntary speech patterns. It is not necessary for the production of innate vocal pattern, such as non-verbal emotional vocal expression in humans, but also in the primates. And we also know that patients with lesion of the motor system, including also Broca aphasic patients, are not completely mute because they can still produce non-verbal emotional sounds, such as crying, moaning, laughing, and so on. On the other hand, the other system that I call system first, system one, is anchored or controlled by the anterior cingulate. You should see the red region in the left panel representing the anterior cingulate. This region is involved in the emotional and motivational aspect of human and animal vocalization. And we also know that patients with lesion in this region have a reduced motivation to speak. In this case, the patient typically do not start a conversation on their part, but only respond to questions posed by others. And we also know that the stimulation of this region in the animal produce emotional vocalization. So there are these two alternatives, if you want, albeit interacting system controlling human vocalization. But laughter also concerns muscles of the face, not only vocalization. However, we know that a similar dissociation between the voluntary and the emotional control of emotional expression also exists in the case of the motor control of the face. So here again, you have an anatomical picture showing that the lateral motor system, the voluntary motor system, control the muscle, in particular the muscle of the lower part of the face, the one in orange here, while the anterior cingulate and other region, other so-called emotional region, if you want, control the entire muscle of the face, including the upper part of the face. And in this case, the control is not under voluntary controls, but it's triggered by emotion. This is a nice example. The woman in the picture is a patient with a stroke in the left motor system, and when asked to voluntarily smile and laugh, as it happened in the left panel, she is unable to produce a full smiling expression. As you can see, she's able only to laugh with the contralateral, the ipsilateral part of the face, ipsilateral to the lesion. Okay, because there is no control of the part of the face contralateral to the lesion. However, she is still able to produce a full smiling expression if the neurologist tell the woman a joke, so she starts laughing or smiling because she was when she's triggered by some kind of emotional situation. In this case, the emotional system bypass the voluntary motor system and activate both left and right muscles of the face. Okay, so this is a case of dissociation between the two systems. And this is very interesting because if you consider that, for example, there are studies on basic emotion suggesting that there is a difference between the voluntary smile and a spontaneous smile, and this difference in particular lies in the lower recruitment of the upper part of the face during the fake smile, if you want. So the reason why this story has been told in the past is probably because it's more difficult to activate voluntarily the upper part of the face, because the voluntary motor system control mainly the lower part of the face. So it's more difficult to train your motor system to activate also the upper part of the face. So this is probably one of the reasons why Paul Ekman, for example, suggested this kind of dissociation. Now some evidence today suggests that the passive observation of dynamic facial expression of happiness activates the emotional system in the anterior cingulate cortex. So more in line with the second, the emotional mirroring model, the one on the right panel, if you remember. Okay. In fact, for example, in this study, the study suggests that observing happy expression, smiling expression, for example, trigger an automatic facial mimicry measured by means of EMG activity, but at the same time, facial mimicry correlate with the activation of the anterior cingulate cortex and other emotional regions, such as, for example, the amygdala. As you can see, 3 stars means very strong activation. And however, activation is not correlated with the activation of the motor system. So the primary motor cortex and the premotor cortex gave no significant results in this case. So it seems that facial mimicry is more strongly driven by the activation of the emotional brain system. Okay, and this is more in line, as I said before, with the emotional mirroring mode. the motor cortex, in fact, is not activated. This is another study we performed thanks to our collaboration with the Epilepsy Surgery Center in Milano. We discovered that the anterior cingulate cortex, which is part of the emotional system, elicit laughter when electrically stimulated, in line with, if you want, monkey studies showing that electrical stimulation of this region induce emotional localization. But however, we also find that if you present a patient with video clips of actors posing laughter or neutral expression or negative expression, there is an increase of activity in the very same size whose stimulation elicit laughter only during the observation of other laughter. So, in other words, the observation of dynamic video of laughter activate the anterior cingulate cortex, and this is coherent with the hypothesis that this region hosts a mirror mechanism for laughter. So when you observe another individual posing laughter, the visual information is directly projected to the anterior cingulate cortex, and this is also in line with the unmediated emotional mirroring model rather than with the reverse simulation model, because also in this case, the motor cortex is not significantly activated. In fact, we also try the same thing by studying the frontal operculum, which is part of the voluntary motor system, and we discovered that even if it is possible to elicit smile and laughter by stimulating the voluntary motor system, during the passive observation of other laughter, this system is not activated. So it seems that the anterior cingulate is activated, but not the motor system. Once again, in line with the unmediated emotional mirroring model. So summing up, the anterior cingulate, the system one, if you want, is activated by other laughter through a mirror mechanism, and it contributes also to facial mimicry of happy expression. So, however, there is still a question we have to answer. What is the contribution of this region to laughter production? So why the visual information is directly projected to this region? This is still a missing point. So in 2015, we analyzed a number of electrical stimulation in patients following the stimulation of the, we analyzed the results of the electrical stimulation following the electrical stimulation of the anterior cingulate cortex, and we discovered that the stimulation of this region elicit laughter, but often this laughter is also accompanied by a sense of mirth and merriment, even verbally reported by the patient, as if the same region controlled both the motor pattern of laughter and the affective aspect of laughter, more or less in line with William James' theory of emotion. And this evidence has been confirmed subsequently in 2019 by in this paper published by the Epilepsy Surgery Center of Atlanta. They first of all replicated our stimulation data, confirming the involvement of this region in the production of mirthful laughter, if you want. But they also had some very interesting insight. Maybe I can show you a clip. During the stimulation, let me see if, are you able to see the, can you see the clip? Yes. Marco? Okay. So during the electrical stimulation, first of all, they stimulated the same region, and in the meantime, they asked the patient to frown, so to resist this urge to smile, and the patient say it was basically impossible. This is the example. As you can see, she's now trying to frown. In the meantime, they are stimulating continuously the same region, and the patient say, I can't. And this is even more interesting because in this case, they ask the patient to remember something said. And once again, as you can see, as you can read, the patient, cannot but laugh and say, I know they are sad memories, but they don't come up as sad memories. So this clip demonstrates that the contribution of this region is not limited to the motor pattern of laughter. It also involves an affective element. Finally, this is an MRI study on the neural basis of subjective happiness. Here, the author demonstrated that trait-like subjective happiness measured by using behavioral tests was positively correlated with gray matter density of the rostral anterior cingulate cortex, so measuring basically the cellular density or the gray matter thickness of the anterior cingulate cortex, showing that there is a correlation. People with high rate of happiness measured by using this behavioral test is also people with gray matter density, with gray matter, more thick, if you want, anterior cingulate cortex. And subsequently, they also conduct an fMRI study using a positive emotion induction task, and they found that induced happy feeling were positively correlated with subjective happiness level and anterior cingulate cortex activity. So, according to the author, this study demonstrates that this region, the anterior part of the cingulate cortex, is both structurally and functionally associated to subjective happiness. Okay? So, summing up, dynamic expression of happiness directly activates the same center controlling the production of mirthful laughter. And if we go back to our original picture, derived from Alvin Goldman suggesting about the possible simulation models sustaining mental simulation, it seems that there is some evidence that the anterior cingulate activation is more in line with the unmediated mirroring model, because it seems there is an activation during the observation of emotional facial expression, a direct activation of the anterior cingulate cortex, but not an activation of the motor system. So more in line with the unmediated mirroring model. What could be the peculiar function of this system? Why do we have this kind of unmediated mirroring system? Is it for emotional understanding, for example, or for something else? I would say for something else. This is the reason is based on this study by Robin Dunbar. Robin Dunbar suggested that human laughter replaced social grooming as a strategy to enforce affiliation within in-groups. According to Dunbar, primate society are based on coalition that are enforced by a neurochemical mechanism active during social grooming. Social grooming is accompanied by a release of opioid in the recipient, and this opioid system activation established and maintain long-term social relationships. So basically, social grooming is a strategy to create affiliation and social bonding between individuals. However, and this is the thinking of Robin Dunbar, grooming exploits the somatosensory channel, but in the course of evolution, ecological pressure have led to an increase of the size of social groups, in particular human groups. So when the size of human group exceed the network that can be maintained by social grooming, we develop an alternative strategy to create social bondings. And according to Dunbar, laughter is precisely that type of new tool, if you want. So laughter, in fact, creates social bonding, according to Dunbar, by using the visual and auditory channel rather than somatosensory channel that, of course, can be useful only in dyadic relationship. Because if I want to create affiliation when I speak to many different people in the same time, of course, I cannot rely on the somatosensory system because, of course, it's not impossible. So the laughter using the vocal and the auditory and the visual system can create social grooming, can in some way create affiliation using this alternative channel. And to demonstrate his hypothesis, Robin Dunbar go to Finland, met Laurin Manna, who is very able in the study of the opioid system in the brain, and they perform a very interesting study. Basically, they ask subjects to view comedy clips with friends before undergoing a PET scan with a ligand specific to mu opioid receptor. Subsequent, in the other group, in the control group, the same subject have to view very boring clips by themselves. And they demonstrated that the mu opioid receptor availability increasing the anterior cingulate cortex and other region only in the group of individual observing laughter, very funny clips with friends. So laughter increase the availability of mu opioid receptor in the brain. And this, of course, is useful to create new affiliation and social bonds because, of course, it's a kind of vicarious social grooming system. Okay. This is a picture from a review by Viola and Preston on empathy. And according to Viola and Preston, empathy is a multi-layer phenomenon. But interestingly, emotional contagion based on emotional mirroring is at the origin of empathy. Is one of the, is at the core of this Russian doll model of the evolution of empathy. And as you can see in the picture, the anterior cingulate housing emotional mirroring for laughter is considered to be a keynote of this system. And so hence the emotional mirroring of other laughter can facilitate affiliation and the establishment of social bonds. So as if the second model suggested by Alvin Goldman, the function of the second model is to create affiliation and establishment of social bonding. And interestingly, this is known by, primatologists has already suggested something very similar when discussing the role of bonobo and chimpanzee laughter. As you can see, this is a quotation from a paper by primatologists suggesting that for bonobo, laughter is a form of emotional communication. It is a signal that tells to other individual, I want to continue playing with you. In the animal world, play is a way to increase social bonding and to boost affiliation. So, of course, as a system, transforming other laughter into our own laughter can facilitate this mechanism. Indeed, we know that laughter is contagious and trigger an automatic simulation imitation, and I suggest you to go and see this YouTube video to convince yourself of the affiliative role of laughter, because in this clip, where this is a very, famous example of contagious laughter, it's very clear to what extent laughter is contagious and to what extent to be contagious by laughter increase social bonding with other individuals. Okay, but what about the second network, the network housed in the voluntary motor system? Is there any kind of mirroring system in this second voluntary motor network or not? We know that stimulating this network, the ventral part of the voluntary motor system, it is also possible to elicit smile and laughter, even if typically in this case laughter is devoid of mirthful sensation. So it seems that only the motor pattern of laughter can be triggered by lateral stimulation, devoid of the emotional counterpart. Moreover, we know that imaging studies show that this part of the brain is active during the voluntary imitation of smile and the voluntary production of laughter. And there is a very interesting study by Alessio Venanti and others suggesting that this voluntary motor system, the second network, for the control of voluntary facial movement is causally involved in specific tasks, such as the task to infer amusement from another smile. So what we did in this experiment is this. First, they asked individual to observe other facial expression. The data set included both real emotional smiling expression and fake expression of smiling and laughter. And the participant had to rate to say if, according to them, the posed expression was a real laughter, real smiling expression, or if it was a fake expression. Subsequently, they electrically stimulate, they use TMS, they use magnetic stimulation over the voluntary motor system, creating a so-called virtual lesion. So in this case, the voluntary motor system was knocked out for a brief period of time, and they asked the participant to perform the same task, and they saw that when the voluntary motor system was virtually lesioned, the capability to infer amusement from a smile was very poor, so for decrease. So it seems that this system is useful and it possibly implements a specific type of motor simulation, but in this specific type of task. I mean, to decode, to understand whether the facial expression, the posed facial expression is a real facial expression or not, okay? A real emotional expression, sorry, or not. And this is a recent study by Sophie Scott and co-workers, very interesting because they found a clear dissociation between the regions recruited during the perception of volitional laughter versus spontaneous laughter. So in their data set, they had volitional laughter and spontaneous laughter, and the subject had to understand whether the observation, the video was presenting volitional rather than spontaneous laughter, and they found that volitional laughter typically activate the voluntary motor system, while spontaneous laughter activate region close to the anterior cingulate cortex and the pre-SMA. And in addition, they also say that spontaneous laughter was systematically rated as more authentic and emotionally contagious. So it seems there is a clear dissociation between two distinct networks that can be activated during different types of smiling and laughter posed by other individuals. So my hypothesis is more or less this. First of all, the first network, the anterior cingulate cortex, hosts a mirror mechanism activated by the passive observation of other laughter, and in particular by contagious laughter. This system controls emotional laughter, and emotional laughter activate the same emotional mirror, the same system controlling my own emotional laughter. It activates the opioid system and facilitate affiliation and so on. On the other end, we have a voluntary motor system that is activated not during the passive observation of other laughter, but rather during the observation of very challenging facial expression that is not easy to understand whether they are really, genuine emotional expression or not. So during this very challenging task, the voluntary motor system enters the stage because we need some kind of machinery to understand the unclear facial expression posed by the other individual. So, in other words, it seems that both systems likely implement different types of simulation mechanisms, but these two systems differ in terms of input because the reverse simulation is triggered by voluntary, unauthentic, ambiguous, challenging facial expression, while the emotional mirroring system housed in the anterior cingulate is triggered by spontaneous and contagious laughter. The reverse, the neural circuitry is completely different because in the case of the reverse simulation, the core of this system is housed in the voluntary motor system, while in the other case, the core region is the anterior cingulate and the emotional region more in general. And of course, the computational model is different because, as previously hypothesized by Goldman, there are computational models very different in the two cases. So this is basically my final picture. As promised, the talk was shorter than expected, not 1 hour, but thank you for your attention.